Hello fellows, in today's video we'll be looking at the derivation of the formula for the sum of arithmetic series. Okay, now the sum of the formula for arithmetic series is given by the formula Sn is equals to n divided by 2 into 2a plus n minus 1 into d. It is normal and it is not a sin for one not knowing what this actually means. You know, for now this is supposed to be an open island. This is supposed to be strange to you. It's understandable because you have never done this. Okay, but now what I'm sure of is if I remove the 2 here and you remain with a plus n minus 1 into d, then you become happy. You remember that, oh, we once talked about this thing when we were dealing with arithmetic series in grade 11. However, let's get into it and let's just hop into it. Okay, now let's recap. There are certain things that one is supposed to put into consideration if you are to understand the derivation and the proof of the sum of number of terms of an arithmetic series. One, let's check it. What is a series? A series is a sum of terms in a sequence. When you were in grade 11, you only talked about a sequence which was given by consecutive terms or successive terms that were separated by semicolons. Okay, so now immediately when you start to separate the terms with an addition sign, then the sequence changes and it becomes a series. Okay, so every time when you see the word series, think of a sum. What are you summing? Summing, it means you are adding. What are you adding? You are adding terms in a sequence. Okay, if you are adding terms in an arithmetic sequence, then it becomes an arithmetic series. If you are adding or summing terms in a geometric sequence, then the series becomes a geometric series. Okay, so the difference between a series and a sequence is just that a sequence is just terms that are separated by a semicolon, and a series is the terms of a series separated by addition, or there will always be a plus sign between any two successive terms in that particular sequence. Right. Secondly, you should remember that in every series, in every arithmetic, not just any series, in every arithmetic series, you will always find the common difference. So it means every arithmetic series has a common difference. And put this in mind, because at some stage in the next video I'll be dealing with the geometric series. So in a geometric series we don't talk about the common difference, we talk about something else. Okay, so remember, this is a special feature for arithmetic series, the common difference. It means the difference between any two successive terms is the same, it's common. Okay, now another thing is, when you want to determine this difference, which is the same or which is common, you always take the succeeding term, you subtract the preceding term. Succeeding term minus the preceding term. The next term minus the previous term. Okay, next term minus the previous term. So it will always be given by T2 minus T1, which must always be equals to T4 minus T3. If T2 minus T1 is not equals to T4 minus T3, then the series doesn't qualify to be called arithmetic. Okay, it only qualifies to be called arithmetic series if the difference between T2 and T1 is the same as the difference between T4 and T3, so on and so on. Okay, right. Another thing that we must put into consideration is that when you see T1, T1 means the first term. It means term number 1. Okay, and term number 1 can be denoted is the same as A. If somebody writes A for the first term and another one writes T1, they are talking more or less the same thing. Okay, these are synonyms, they are the same. Okay, if you don't want to say T1, you say A. So because in the formula we deal with A, we need to acquaint ourselves with the utilization of A in state of T1. Okay, another thing is N will always denote the number of terms in the series. Okay, so we need to know how many number of terms are we summing, and then those number of terms will be represented by N. Okay, so another thing that we must put into consideration is that when we are dealing with arithmetic series, in order to determine term number 2, you actually need two things. You need the first term, you also need the common difference. Okay, but there is something that I want you to realize here. If you check here, when we say term 2 is equals to A plus, look at D as 1D. Look at it as A plus 1 multiplied by D. So it means the coefficient of D is 1. Why is it important to actually put it in that fashion? Because there is a relationship between the coefficient of D and the N. Our N in this case is 2. Okay, because there will be 2 terms if you say T2. Okay, so 1 is actually 1 less the N. So every time the coefficient of D in an arithmetic series, it will be 1 less than this. So it means if this is 2, here it will be 1. If this is 3, here it will be 2. If this is 4, here it will be 3. So the coefficient is always 1 less than the number of terms. So it means when you have T3, it will always be A plus 1 less. So it means 3 minus 1, which will be 2. And then you have A plus 2D. So by default, it means if it can be T7, you will actually have what? A plus 6D. If it can be T11, it will be A plus 10D, just like that. So the question is, what if we don't know N? We don't know the value of N. If it is just N, then what will happen? It means we'll have Tn. Instead of actually having a 2 here, it will be N minus, you see, the same way that we do. So because here we set 3 minus 1, which gave us 2, it means even here the coefficient of D must be 3 minus 1. So our 3 in this case is N. So it must be N minus 1, which is N minus 1. And then we multiply it by D. So the coefficient of D here is N minus 1. And it is not for the first time you see this. Okay, if you passed your grade 11 well, you know very well that this is a formula to determine the general term of an arithmetic sequence then. But now we are dealing with a series. Okay, so the same principles that we use with the sequence is the same principles that we use with the arithmetic, with the series. Okay, now another thing is, you should also understand that Tn is actually the general term, which can actually give us the last term of the series itself. Okay, last term of any series. Okay, so in this case, if we know the last term, instead of writing Tn, we can just denote it by L. Okay, because sometimes the series is finite, sometimes it's infinite. Okay, if it is finite, it means you know the last term. If it is infinite, it means we don't know the last term. And if it is infinite, then it will be represented in this fashion. It means our last term will be Tn. But if it happens that we know that Tn is 10, then it means our last term will be 10. So put this into consideration, because as we continue, I'm going to be incorporating A plus N minus 1 into D and L in the formula that we will derive. Okay. Now we are still on the derivation of the formula. Suppose you are given an arithmetic series, which is 1 plus 3 plus 5 plus 7 plus 9. Okay. It means term number 1 is 1, term number 2 is 3, term number 3 is 5, term number 4 is 7, and then term number 5 is 9. Okay. But how sure are we that this is an arithmetic series? And remember, this is a finite arithmetic series. Why? Because we know the first term and the last term. Okay, it doesn't continue. If it was continuing, it will be having plus ellipsis plus 3 dots. Okay, but now because it just says 1, 3, 5, 7, and 9, it means it is finite. It means it is definite. It ends. It terminates. Okay, now let's check. If it is arithmetic series, what is the common feature? It must have a common difference. So it means the difference between any two successive terms is supposed to be the same. Okay, so in this case, if you say 3 minus 1, it will be 2, 5 minus 3 is 2, 7. So it means in simple terms, the common difference, which is small letter d, do not use capital letter D. Small letter d is the one that denotes the common difference. It means the common difference is what? Is 2. And remember, this is the first common difference. You remember very well that if you can actually have the second common difference, then it means the sequence would be a quadratic sequence. But in this case, because the first common the first difference is common, then it is arithmetic series. Okay, so it means our d is equals to 2. Now let's check. How did we get this particular 2? How did we get this 2? We said 3 minus 1, which is succeeding term minus previous term. How did we get this 2? The same thing apply. 5 minus 3 is for that 2, and then 7 minus 5, that 2, and then 9 minus 7 is for that 2. Okay. Now, T2, which is 3, minus T1, okay, is the one that give us 2. Okay, so it means the 3 minus 1 represents T2 minus T1. Okay, and then the 3 minus 5 will actually represent the T minus T2. I mean T3 minus T2. Okay, now let's check. We said to determine D, you take T2 minus T1. So T2 minus T1, T3 minus T2, they are equal, they are the same. It is 2 and 2, then is the common difference. But how many number of terms are we actually having? Okay, we are actually having 5 terms. That is why our n is equals to 5. But remember, when we were recapping, we said if you don't want to say T1, you can say A. And in this case, our first term is what? It's 1. So the 5 that you see here, okay, is actually the 5 that you see there. Okay, this is the 5. Okay, so this 5, it means number of terms are 5. Okay, so be careful. Let's interpret this. There are 5 terms of the series, but the 5th term, term 5, is 9. Be careful. There are 5 terms, okay, of the series, and the 5th term is what? It's 9. And the first term, which is A, is equals to 1, and the common difference is equals to 2. Okay, that is the interpretation. Now let's check it. In this case, we know the last term. We can't say T5 is equals to what, just like that, because we know very well that the last term is equals to 9. So instead, we can actually just write L is equals to 9. Or if I say T5 is equals to L is equals to 9, this will be correct. Okay, we know. Now, moving along. If we decide to use the same arithmetic series, okay, it means there will be 5 terms of the series, and this will imply that now n is equals to 5 if there are 5 terms. Okay, now we are summing. We want to sum. If we say 1 plus 3, it will be 4. 4 plus 5 is 9. 9 plus 7 is 16. 16 plus 9 is equals to 25. So it means when we sum number of terms, they give us what? 25. Okay, so when you say S5, you are saying sum of 5 terms. 5 terms of what? Of arithmetic series is equals to 25. Okay, now that is the first term. Term number 1, term number 2, term number 3, term number 4, term number 5. Hence, that is why we are actually having this 5. So when you say there are 5 terms, it's because we can actually count them. There are 5. But the question is, what if there were not 5? What if there were 1,000? Or what if there were 3,000? Would it be wise to add all of them until the 1,000, the 100th term, the 1,000th term, so on and so on? It will take us time. So we need a mechanism. Okay, we need a way. Okay, we should actually develop a way of actually calculating the sum, irrespective of how many number of terms they are there. And that is exactly what we're going to derive. Okay, now let's check. Let's find the quickest way of summing number of terms of this series. This is what you will do. You will actually tell somebody to say, I have a series which is arithmetic. Okay, why is it a series? Because terms of the series are separated by what? By addition. And by the way, this is a finite series because we know the last term. Okay, now we want to come up with a way, the quickest way of actually getting 25. Okay, so what you do is you tell somebody that I'm going to sum how many terms? 5 terms. Okay, 5 terms of which series? The series that is generated by 1, 3, 5, 7 and 9. So the quickest way of summing this is, the first step would be, we should rewrite this series in a reverse. Okay, so in reverse, it means the last one becomes the first one, the first one becomes the last one. Yes, very simple. So it means if I write it again in reverse, then the sum of these are still the very same 5 terms that we're talking about. So it means in a reverse, the first term will be 9 and then the last term will be 1. So you just write it in reverse. It will be 9 followed by 7 followed by 5, 3 and then 1. Okay, now what we can do is we can actually say, okay, let the original sequence, okay, the one that we didn't tamper with, this one, let it be equation number. Okay, and then let the second one be equation number 2. Okay, let me underline this so that you see sorry, exactly what I'm talking about. Okay, now what we're going to do is, after rewriting the original in reverse, then we add the 2 and then you will realize something. Okay, which is what I want you to realize. So let us add the 2. We'll actually take equation number 1 and we add it to equation number 2, and then it means S5 plus S5, because these are like terms, then you just add them. You will actually have what? 2S5 is equals to 1 plus 9 is 10, 3 plus 7 is 10, 5 plus. So you start to, you observe something, you realize something here, to say, oh, every time when I take 2 corresponding terms of the original series and the reversed series, the answer is the same, is common. Okay, it will always be 10, 10, 10, 10, 10, 10. So it means we don't need all these 10s. Because it is common, we'll just take only 1 10. Okay, so for us to determine the 25 that we're having here, you look at how many number of terms you are having. If you are having 5 of them, you take your number of terms, you multiply it by the common sum of the corresponding terms of both the original and the reversed. So it means if here it was 7, you will multiply 5 by 7, but because it is 10, you multiply 5 by 10. Okay, so in simple terms, it means 2S5 is equals to 5. You take this 5, you see this 5, which is this one, it's number of terms. Okay, you take this 5, which is this one, you multiply it by what? By 10. Where does the 10 come from? The 10 is the common 10 that we get. It's the common sum. Okay, it's the same. it will be the same. It will be 10, 10, 10. There is no need for us to take all the 10s because they are the same. We just take one. Okay. So when you say 5 multiplied by 10, it will give you 50. But we are not interested in 2s5. We are interested in s5. Therefore, we can divide both sides by 2. Okay. Then we have Sn is equals to 50 divided by 2, which will actually give us 25. But now, this 25, the 25 that we're talking about here, is the one that you see here. Maybe let me just draw a line so that you see what I'm talking about. Okay. So the 25 is the same 25. Okay. So instead of saying 1 plus 3 plus 5 plus 7 plus 9, what did I do? I just write the series. From there you write it in reverse. After writing it in reverse, you add the original and the reversed one. Okay. Then the common sum that you get here, you multiply it by a number of terms, and then you divide both sides by 2. Then you get your 25. So this is the quickest method that you can use for summing any number of terms of a series, of an arithmetic series, just arithmetic. Okay, if it is arithmetic. So it means this is a method, or the quickest way that you can use if and only if you are summing number of terms of an arithmetic series, not any other series. Okay. Now we are going to use the same principle in order to determine the general the formula for the sum of number of terms. A question is sorry, what if we didn't know? What if the series was not finite? It was infinite. What if we didn't know the number of terms? What if the 5 was an n? Okay, that is basically what we want to know. Okay, now moving along, let's check. Suppose you are given an arithmetic series. In an arithmetic series, the first term, which is t1, it will be given by a, and every time when you want to determine this, the succeeding term or the next term in an arithmetic series, what do? You take the previous term, you add it to the common difference. Okay, and then if you have the last term and then you want to know the previous term, what do? You take the last term, you subtract. So it means when you move from the end to the beginning, you subtract the common difference. But when you move from the beginning to the end, you add the common difference. Okay, so for you to understand me better, let me put the series that we were dealing with. Okay, so now you have a picture. Now the 1 is represented by a. Okay, in order for me to get a 3, I must do what? I must add the common difference. And remember, our common difference was what? Was 2. So 1 plus 2 is 3. Okay, so a plus d will give me 3. Okay, but now if my last term in this case is a general term, which is tn, if it is 9, if I want to get a 7, so it means I want to know the previous term before the last term. What do? I say 9 minus 2. So the same thing apply here. We'll say a plus n minus 1 into d minus our common difference is what? Is d. And then if you say a plus n minus 1 into d minus d, then it will give you a plus n minus 2 into d. So it means a term before this one, it will actually be a plus n minus 3. Then it will continue a plus n minus 4. But when you move from the left going to the right, okay, then it will be a plus d. Remember, the third one will be a plus 2d, because it will always be the coefficient will always be 1 less. It will be a plus 2d, a plus 3d, a plus 4d, just like that. Okay, now we want to use the same principle that we used for 1 plus 3 plus 5 plus 7 plus 9. What did we do? The first step is you write down the series. Okay, you write it down. This is exactly what we did. Okay, in the previous slide, what did we do? We said S5 is equals to 1 plus 5 plus in this case, but in this case we don't know n. That is why we say Sn. And then the general sum of an arithmetic series is given by what? A plus d, plus there will be other terms in between, but we know that the last one, which is Tn, the one that you did in grade 11, is given by a plus n minus 1 into d, but we know the one before it it will no longer be minus 1, it will be minus 2. The one before n minus 2, it will be n minus 3, so on and so on. Right. Okay, the first step is you write down there the series. What was the second step? Exactly, you remember, you write the series in reverse. So if we write it in reverse, it means a will correspond with a into n minus, a plus n minus 1 into d, and then a plus d will correspond to a into n minus 2 into d, so on and so on. And then a plus n minus 1 into d will correspond with a. Okay, maybe let me just underline so that you understand what I'm talking about. Okay, then what was our second step? Exactly, you remember, you add. You remember, the first one, we'll call it equation number 1, this will be equation number 2. You add the 2. Okay, these are like terms, so Sn plus Sn will give us 2 Sn. And then when you say a plus n minus 1 into d, automatically we're going to have what? A plus a, which is 2a. Okay, so you will have 2a plus n minus 1 into d. But remember, when we were adding 1 to 9, we got the same thing. It was 10, 10, 10, 10. So it means the sum of these two corresponding will be the same throughout. So it means if the sum of a plus n minus 1 into d is the same as 2a plus n minus 1 into d, then it will be the same throughout. Okay, so it means our 2Sn will be equals to 2a plus n minus 1 into d, but it's supposed to be the same throughout. The same way that we got 10, 10, 10, 10. And remember, we are not going to take all of them, we just take only one. Okay? And remember, in order for us to get the 25, what did we do? We set 10 multiplied by a number of terms. Okay, so the same thing apply here. Our 10 is represented by 2a into n minus 1. Okay, our 5 is represented by n. Okay, so it means we'll actually take this n. You see this n. This n is the one that represents our 5. We take n, we multiply. You remember we took 5, we multiplied by what? By 10. But in this case, what is our 10? We'll take that n and then we multiply by our 10, and our 10 in this case is this part. Okay, 2a plus n minus 1 into d. So it is n multiplied by 10, 5 multiplied by 10. Our 5 is n, our 10 is what? Is 2a plus n minus 1 into d. So we multiply, we take this, which is this part, we multiply it by what? By n. Okay, so we have 2Sn is equals to n into that, but we are not interested in 2Sn, we are interested in Sn, which will be the sum of number of terms of an infinite arithmetic series. Okay, so this will be given by Sn is equals to, so you divide both sides by 2, then you remain with what? With n divided by 2. Remember, this is multiplication. Okay, the 2 is dividing everything, so logically it will be Sn is equals to n divided by 2 into 2a plus n minus 1 into d. Okay, remember this formula, people. You see, this is the formula to determine the sum of any number of terms of an arithmetic series. It means this formula, this engine, will only work provided the series is arithmetic. And when the series is arithmetic, it means it has what? It has a common difference. And how do you get the common difference? You take the succeeding term, you subtract the preceding term. You take the next term, you subtract the previous term. Okay, so it means this formula would imply that I can actually expand it. Okay, if I expand it, it means 2a is the same as a plus a. Okay, but remember this part, this part represent what? It represents the last term. I said I will talk about the last term. This represents the last term. This is Tn. Okay, so that part will represent the last term. So it means if my series is finite, if I know the last term instead of writing the whole 2a plus blah 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 blah, I can actually substitute a plus n minus 1 with L. So it means my formula will actually change and become Sn is equals to n divided by 2 into a plus L, so that you don't substitute many variables. You don't n and d, so on and so on. If you know the last term, instead of actually substituting n and d, I can just write the last term. So in this case, it means I would write my last term as what? As 9. Okay, but people, you only use this formula. You use this formula, Sn is equals to n divided by 2 into a plus L, provided you know the last term. Okay, provided the series is finite, provided the series terminates. Okay, if the series doesn't terminate, then it means you'll use Sn is to n divided by 2 into 2a plus n minus 1 into d. Okay, now these are the two formulas that we have derived. Okay, so it means the formula to determine the sum of an arithmetic, a number of terms of an arithmetic series, is given by Sn is equals to n divided by 2 into 2a plus n minus 1 into d, provided the series is infinite. But if the series is finite and you know the last term, you can actually use Sn is equals to n divided by a plus L. So these two are the same. The only difference is with this one you don't know the last term, with this one you know the last term. Okay, so under general, or in conclusion, the formula for the sum of arithmetic series is given by Sn is equals to n divided by 2 into 2a plus n minus 1 into d. I said at the beginning this was strange automatically for you at the beginning, but now you know what does the Sn represent, what does the n represent, what does the d represent. Okay, so if the question says determine or calculate the sum of number of terms of an arithmetic series, the formula for the sum of arithmetic series, then you will actually use this one. So it means if you know n and then you know a, you can calculate d. If you know d and then you know a, you can calculate number of terms, which is n. Okay, and remember, sum of number of terms will always work if we are dealing with the series, because the series, it means you are adding number of terms of a sequence. Okay, so this formula, you need to know this formula, you need to memorize it, you need to put it somewhere in your body, any part of the body that you can use to remember this. Okay, do not rely on the formula sheets. Okay, just know this by any part of your body that will help you remember. Okay, so Sn is equals to n divided by 2 into 2a plus n minus 1 into d, where n is actually the number of terms and a is actually the first term, which is t1, and d automatically or by default it becomes the common difference, the first common difference. Okay, now please subscribe to my channel, like and share, and don't forget to hit the notification button so that you will be notified of future videos. And then if you missed the previous videos, my previous videos, please follow the link, use the link below or the links below for other videos. So the link will either take you to a grade 10 content or grade 11 content, depending on what the video was all about. So people, I will reiterate, please subscribe to my channel, like, share, and then hit that notification button so that every time when I upload a video, you are notified immediately. I love you. Have a wonderful day, wonderful evening, whatever time that you are watching this video. Thank you for watching. See you in the next video. My name is Mr. Madleviani MS, the most complete mathematician you can ever find. Thank you very much.